All right, so this is my last video for chapter 1 for Algebra 2. So we're just going to kind of put all of this solving equations stuff together. We are going to solve this system of equations, negative x plus 2y equals negative 2. And then the second one is x equals 6y. Okay, you guys now have many different ways to solve this. One, I could graph these and see where the lines cross. Where they cross is going to be the coordinate points are going to be the solution set, right? So if I wanted to do this by hand, I can rearrange them all into slope-intercept, graph them, find where they intersect. I could type them in Desmos as is and see where those lines cross, right? That's one thing. So one way we can solve this graph, and that's one way I'm not going to show, right? But you guys can do that on your own if you want to show it on Desmos. The second way is we can solve it algebraically. So let's do that here. We solve this algebraically. Hopefully you're remembering what you can do. First, I need to make sure that they are, well, actually, I'm going to just go ahead and I'm going to substitute to solve it algebraically. Let me switch to pencil. Because I see right here it's already set up for me that x equals 6y, I'm going to substitute that into the top equation. So I'm going to take negative x plus 2y equals negative 2 and substitute in x equals 6y. So that's negative 6y plus 2y equals negative 2. That leaves me with negative 6 plus 2 is negative 4y equals negative 2, which leaves me with y equals positive 1/2 when I divide by negative 4. Okay, now that I know that y is 1/2, I can go back in and solve for x. X equals 6 times 1/2, so x has to be 3. Right, there's my solution set, 3 comma 1/2, right? This is probably the easiest way to solve it, right? But we know some other ways, and the reason we learned about matrices is not because it's the easiest way to solve this particular problem, but because it's something you can use for more advanced problems later. So let's solve it with matrices. So let's set up my matrix. Well, it's negative 1, 2, and negative 2. And here I need to rearrange it. So I'll come over here. Let me close my matrix up. And remember, I need to get my x's in one column. So I know my x, my coefficient is 1. And if I move that over, you end up with x minus 6y equals 0, right? If I pull that 6 over to the left side of the equation, so then I have minus 6 and 0. Remember, my goal is to get it in reduced row echelon form. So my goal is that. All right, so I'm looking at this. I've already got a 1 up here, and it's just negative, so I could probably change that. But then I'm also looking, I could combine these right away to get this 0 down here that I want. So let's do that. So my first step is going to be, label this A, label this B. I'm going to leave row A alone for right now. I'm going to combine these. Negative 1 plus 1 is 0. 2 minus 6, 2 plus negative 6, if you want to say it that way, is negative 4. And negative 2 plus 0 is negative 2. And I'll put a note here that I got that by adding those. All right, and just like I said before, now I have my 0 here. I can easily make that a positive 1 by multiplying this whole row times negative 1. So that makes my new matrix 1, negative 2, 2. And then my bottom one is the same. My bottom row I have not changed. Okay, now I have my 1 and my 0 set up. So now I'm just worried about these two, this last column right here, right? So what I'm noticing is I could divide this bottom row by negative 2, and that would be simplified a bit. I'm just going to try it. Let's divide it by negative 2. You can always go back and try a different way if it doesn't work. So let's divide this row by negative 2. 0 divided by negative 2 is 0. Negative 4 divided by negative 2 is 2. And negative 2 divided by negative 2 is 1. And to me, just so you can see the reason, yes, they are both factors of negative 2, but also that was extremely helpful because I have a negative 2 here, and what I've just done is made this term underneath it a positive 2, so now I can eliminate it. So what I'm going to do is I'm going to add my 2 rows and replace my top row with it. So 1 plus 0 is 1. Negative 2 plus 2 is 0. 2 plus 1 is 3. And my bottom row stays the same. So I'm just going to write what I did here was a plus b. Now you can see I'm getting closer. This is the only term that I have left to change to a 1. And I can get that to be a 1 by dividing by 2. So let's do that. So if I take my matrix 1, 0, 3, 0, 2, 1, and divide this bottom row by 2, I'll have it in reduced row echelon form. I will have 1, 0, 3, that top row doesn't change. 0 divided by 2 is 0. 2 divided by 2 is 1. 1 divided by 2 is a half. So this is it. I met my goal. I have 1's down the diagonal. So my solution is x equals 3 and y equals 1/2, which matches what I got up here. Scoot it up. So that's a match. And then you can do your matrices by hand, which we just did, but now let's check it with some tech. Get my calculator out. So remember what you do. Clear that out. Is you got to go to your matrix function. So second matrix. We're going to edit matrix A. I already went a step ahead and made it a 2 by 3 and typed in the matrix here. So those match, right? Now I go back to second matrix. This time I go to math. And remember, I go all the way down to the one that says reduced row echelon form, the B, RREF. Hit enter. Oops, hold on. Second matrix, math, RREF. Of which matrix do I want to find the reduced row echelon form of? I want it to be matrix A. So I'm going to go to second matrix, click on A, hit enter. There's my solution. It matches what we have down here. 1, 0, 3, 0, 1 and a half. Okay, so that's how we've just taken all of those different ways we know how to solve linear equations and put them all together. And you guys are going to practice that today, solving them by hand, algebraically with matrices, and then checking using your calculator.